Sue is a hydrogeologist with the Conservation Survey Division and School of Natural Resources. Her main research emphasis is on understanding groundwater in northeast and north central Nebraska, looking at the subsurface geology, as well as collecting and analyzing water level and chemistry data. She's part of the technical team for the Nebraska Grout Task Force and focuses on integrated management of surface and groundwater. This morning, she's going to talk about the geology and hydrogeology of northeast Nebraska.
Hi, I'm Sue Lackey, and when I was told I was supposed to tell you what's going on below the ground in all northeast Nebraska in 10 minutes, I freaked. So, I kind of, just an overview, I divided it into between the glaciated side on the east and the non-glacial on the west. Now, in order to put this puzzle together underground, we've done lots of test hole work with the NRDs, mainly in the last almost 3 decades. And we sample and log those. With that data, we design monitoring wells that gives us an access to the groundwater. And the NRDs set equipment in there to monitor water levels and water quality. And then more recently, the Airborne Electro-magnetic surveys. I've worked with designing them on data analysis. There's been a lot of that. It began originally in 2006 and 2007 with the Eastern Nebraska NRD group. This is a 3D image interpretation of these data for the Bazile groundwater management area. And we have our glaciated area, and yes, I'm shaking, on the east side. And then this area was not impacted by ice sheets on the west. We're gonna look in a little more detail at 2 locations. On the eastern side in the glaciated in Pierce County, we're gonna look at a test hole and monitoring well data. And then also in Antelope County on the west side. This test hole was done in '04 with the upper Elkhorn. And in this area, we had some sandy silt at top with clay at the base before we penetrated our sand and gravel aquifer. And then we penetrated the Ogallala aquifer at roughly 145 feet and went through quite a bit of that before we hit our bedrock, which is the Pierce Shale in this area. From these data and the samples, we designed 2 wells, 1 shallow one in the sand and gravel, and then 1 deep one about 265 feet in the Ogallala. Now we're going to take a look at some of the data. This is the depth to groundwater, approximately 3 or 4 readings per year when samples were taken. This is northeast of Royal. And what we see here are, you can see climatic variations. This is my old slide. Oh well. So when we came out of the 90s, this is '01 all the way up to 16. We came out of the 90s, we're very wet, so our water levels were generally high, and then went into the dry period in the early 2000s, and then we started getting wetter until the year when everything flooded, before this last year, 2010, and then we hit 2012, extremely dry. So you see those natural variations, roughly 7-foot variation can be caused just by the climate itself. And then we also notice in-season variations due to irrigation pumping. The natural system here has an upward flow potential. The water level in the Ogallala is higher than what it is in the sand and gravel. But when we start pumping in this area, the potential is actually down. So we're reversing the potential for vertical flow direction during our irrigation season. And roughly the in-year change is about 3 to 5 feet, depending on the year and the need. This is a graph of the nitrate concentrations in ppm. So our shallow well in the sand and gravel is very high. We're going even over 30 parts per million. The low's about 18 parts per million. This is our drinking water standard at 10. You'll see the variations. It does look like we had a change right about in 07, where maybe some practices were applied where we're seeing a bit of a decrease. Obviously, this is the Ogallala Aquifer, the deep well down below, which is running about 2, which is considered pretty much natural concentrations of groundwater nitrate. The only thing where it looks like we're seeing any type of mixing is maybe in 2013. We're seeing it decrease in the sand and gravel aquifer and increase in the Ogallala. One point in time does not tell the whole facts, so we need to get more information on that. And then we're going to go east to the glaciated. This is in Pierce County, east of Osmond. And actually, the driller who drilled this test hole is in the crowd. He was recently hired by the Upper Elkhorn NRD. So, Brett, here you go. This one was put in 1998. On the surface, we have our silt with loess, our windblown loess, before we go into what's called a glacial till. It's a clay matrix. It's very tight. It inhibits the downward movement of water. And then about 150 feet, we go into our sand and gravel aquifer before going into the Ogallala. And then the Niobrara chalk is the bedrock in this location. Again, shallow well in the sand and gravel and a deep well in the Ogallala. This is transducer data, so we're monitoring water levels using pressure sensor probes every 8 hours. This is only the deep well. The water levels in both of these were very close together, so we just kept the equipment in the one well, and this is the water levels from the deep well. So you can see, again, your climatic variations. High in the 90s, then we're drier in the 2000s. And then you hit that 2010 and 2012. You also see, if you notice in this location, we're getting a lot more variation during the pumping season. This one is fairly close to an irrigation well, which can be part of the issue. Plus the Ogallala and the sand and gravels are both confined. They're pressure-related systems. So you see these variations. This is the plot of the nitrate concentrations out of the 2 wells. The red is the shallow well, and the black is the Ogallala. Again, the Ogallala is very low. When I saw these results early on in the 2000s, I was surprised. I never expected to see this elevated nitrate level beneath that much clay. And I'll show you the next picture will tell me why. You see the variations that happen during the season on the nitrates in that shallow well. When they start pumping, it'll go from maybe 20 down to 5 parts per million. So what we're thinking is we're getting leakage through the glacial till, which has a lower concentration of nitrates. The only time it looks like, and again, we need more data here, we might have had potential mixing from the Ogallala mixing with the sand and gravel waters, would have been that 2012. We need to get more information to see if that's true or if it could have been just a data bust. The next shot is going to be an interpretation from aerial electromag again, a profile, so it's just a slice of the earth. Okay. And so where that arrow is where those monitoring wells are. And then this is Osmond. This is Plainview. This is an interpretation of the AEM data. Your blues are clays, silts, the tans are kind of marginal aquifer, silts, maybe fine sands. When you get into the yellows and the browns, those are your aquifer materials. And so when we look at this, I can get, right here is where those wells are. So this little yellow right here is our sand and gravel aquifer. Looky over here. That's why we're seeing the high nitrate. It's connected right below all the branches of the North Fork of the Elkhorn River by west of Osmond. If we go right here, we have a potential aquifer boundary. I started over in Wayne going through the AEM data to define these aquifer boundaries. In that area, we see very little nitrate concentration in our sand and gravel aquifer. However, this is indeed, there's a boundary between that sand and gravel aquifer and this one. And then there's a potential boundary over towards Plainview where there's probably still a slight degree of connection between the waters from those two different aquifers. Another potential use that really hasn't been explored yet of the aerial electromag data is really looking closely at defining the recharge areas. This is a interpretation from the work done by AGF in 2016. So we have Creighton right here. The bluish color, that's our highest potential for recharge. What their basis for this is they look for the coarse aquifer material and the aquifer material within the top 10 feet. So in this area, the average is very coarse in those blue areas. In summary, even Mike got the first one before I even said it. Where is he? Yeah. Even Mike knows it's complex and it changes. And so in a broad sense, your main variation is the glaciated on the east, non-glacial on the west. The aquifers, in general, till we get further into Wayne County and that far east, we have the regional Ogallala aquifer below multiple younger sand and gravel aquifers. And there's varied degrees of lateral and vertical connection between all those aquifers. Groundwater levels and nitrates, they're unique to individual aquifers. You can have some extreme climatic variations as well as your seasonal variations during irrigation. So sorting that out is not always easy. Then we have the Airborne Electro-mag surveys, fairly new, but the data is being applied in multiple projects. I'm using it mostly to define these aquifer boundaries and with the data from these monitoring well networks. And then delineation of recharge areas. I know Dan Snow really wants to look into that a little deeper, and that's his expertise. I like the water table down, not up. It's just dirt up there. That's it.